Thank you. Good afternoon. I will try to fulfill the role of moderator. So, what we prepared for today? So we will have 3 presentations. I'll start with the first one that is presented by Jorge Cunha. Jorge Cunha is a Master in Forest Resources Engineering from UTAD. He's a project manager in Forestwise, a collaborative laboratory. He's working in the circular economy and value chains work line and is the rePLANT coordinator. Group management and property consolidation models, forest planning and management, biomass flows, supply chains, digitalization of process and bioeconomy, and are some topics of interest. So, George, go ahead. I don't know if it's Monica with the presentation. Or...
I believe George wants to share the screen, right?
Yeah, I want to share it.
Okay.
Thanks, Rui, for this nice presentation. I think you are already see my screen. Yes?
Yes.
Okay. First of all, I want to thank EDP for the invitation and this opportunity to present the rePLANT project. This project is led by Navigator, a pulp company, and with Forestwise as a technical and scientific coordinator. I will make an overview of the project, and then you are going to see some specific actions that Labelec, Andrea, and Fatima will present. But first, I want to briefly introduce Forestwise for who didn't know what is Forestwise. Forestwise is the collaborative laboratory for integrated forest and fire management, non-profit association founded in September of 2018. We promote integrated forest and fire management based on research and development, knowledge and technology transfer, acting as a link between industry, academia, and the public sector. We are composed by 15 associates, as you can see below here, left of the slide. And counts on a highly qualified technical team of 11 senior researchers and 6 project managers in a total of 21 human resources. We are organized in 4 main lines works, like you will see there. They are in articulation with our research agenda. You can see more information in our website, but the main work lines are management of forest and fire, risk management, circular economy and value chains, and people and policies. So now I'm going to talk about rePLANT. This is in fact a pioneer project, not only on the approach that we decided to do, but also because of the consortium that was established, composed by 20 entities from research to companies from forest and power sectors, technology takers, and finally to some end users of the technology that we are going to develop. The main goal of rePLANT is to contribute to the valorization of Portuguese forests through the implementation of collaborative strategies. These strategies will give rise to new products and services or processes, mostly supported by new digital technologies, introducing a high degree of innovation. That will contribute to improve decision-making in forest and fire management. and we expect that it is going to have high significant impacts through the whole value chain and forest chain. And this is the consortium that is now working within these projects. This is the main structure of the project. It's divided in 3 main work lines that are forest and fire management, risk management, and circular economy and value chains. Each one are coordinated by one enterprise and one member of the academia. As you can see, the first one is the leader is Zona Arauco and the Instituto Superior de Agronomia. The second one is coordinated by REN and Universidade de Coimbra, and the other one by Navigator Company and Forestwise. So these are the main activities planned, but I will not go into detail in each one. I will rather let you know some of the results that we have already achieved, and then you can ask if you want some more information in detail. So in the first one, that are divided in these tasks. The first one is pinus species provenance that are more productive and better adapted to climate change. In order to have species better adapted to climate change and more productive, a set of seeds of different pine species and origins were selected. Tests are being set up with plants from these seeds to study which ones can be more interesting in the future. Take into account the things linked to climate change and so on. So another task is about study of different types of operational interventions with different kinds of equipment in pine natural regeneration stands, with the aim of adjusting operations to different conditions and reducing costs and improvement forest management. These tasks are not finished. So in these two cases, we do not have yet results, but we expect it to be possible to present them by the end of the project, of course, before July of next year. The other two tasks are low-cost, high-quality remote sensing data, forest planning and management. This is one of the results is a forest occupation map using satellite images in real time. So that is available on a digital platform for the members of the project. And the next steps are biomass model and vegetation monitoring around the infrastructures that will be developed. But these new technologies for forest knowledge will allow to collect the collection of information and the evaluation of the current state of the forest. But in relation to this activity, Fatima and Andre, as I said, will present what is being done in the scope of Replent. And the other one is, and finally, in this main work line, is the tests that we are doing in some mobile applications for conducting forest inventory. Usually this process is normally costly, time consuming, and it requires specialized equipment and technical knowledge. With these applications, anyone with a cell phone can do forest inventory in a simple and less expensive way. So we are adjusting some algorithms and the processes that are linked to this. And then I can go through the second work line that is linked to risk management. We have some innovative strategies for using existing infrastructure for forest monitoring. Within the scope of risk management, like I said, task led by REN and the Universidade de Coimbra. An innovative fire surveillance system is being implemented, composed by video, thermal and optical cameras and meteorological stations that allows to us to combine fire detection with fire monitoring, so we can predict which sites could be more critical and making firefighting more proactive. And a real-time decision support system is also being developed to predict the evolution of fires and thus help allocate the resources to the most critical locations, so to be more effective in protecting infrastructures that could be potentially at risk. And in the last one, in this work line, circular economy and value chains, we are working sustainably forests logging and logistics, and mechanization, automatization, and robotization of our forestry operations. We are testing new equipment. This new equipment is being developed based on the concept of partial soil mobilization. This implement integrates digital automatization and sensing tools. For example, for define the depth of soil mobilization, or determine or calculate the amount of fertilizer that must be applied. And this is important for the efficiency of safety of the forest operations and savings in terms of consumption and costs, and with less environment impacts. And the last one, you can see the machinery that is under development. And the other one and last one is about new solutions for remote data collections that are being implemented and adapted in the forest machines in Portugal, mainly for harvesting. And that this information that is collected in real time when the operations are ongoing are connected to a new decision support system for scope that will allow operations to be optimized and combining with information about the teams and equipments that are available in real time, so you can adjust the teams and the equipment to a better and efficient operation. So I think it's all that I want to present. So the project ends at July of next year. So we expect more new results, and you can obtain more information through our communication channels and like the project website and the social network. So thank you for your attention, and I'm available to answer your questions if you want.
Okay, thank you, Jorge. It is a very challenging project, but we believe that the scope will be reached. So now we go to Fatima Santos. Fatima Santos is working in the vegetation management department at Redes. Redes is the Portuguese DSU. She is a forest resource engineer with 19 years of experience and joined EDP Group for 12 years. Having developed some activities such as expropriation, forestry, and environmental projects, and currently in vegetation management planning. Okay, Fatima. Go.
Fatima, we cannot hear you.
No.
Now we can.
You can see? You can see the presentation?
Yes.
Yes.
I'm the one sharing the presentation. Are you sharing?
I'm sharing, see, yes.
Okay, so you should try again because I was sharing.
Okay, it's good. No.
Perfect.
Okay. Thanks, Rui, for the presentation. Hello, everyone. I'm Fatima, and I work at R&D in the department responsible for vegetation management. I will present our activity and participation in the rePLANT project. These slides show where we are in the value chain on the electricity sector. R&D is the Portuguese distribution network operator that also works actively in the defense and protection of the forests to guarantee the safety of populations and improving the quality of service of electrical networks. R&D managing an electrical network with 179,000 kilometers of extension, with 68,000 kilometers of aerial networks, which of these 28,000 kilometers are in forest areas. Okay. This is our intervention area in aerial network. As you can see in the first image, we have a very dense and proliferated infrastructure network. We also show the image of land occupation with special attention to the representation of the forest area in Portugal, where we have 41% of our aerial networks. Okay. As a result of the increased connection of R&D with the forest and vegetation management activities, in 2020, R&D created a new department, Vegetation Management Department, VMD, with the responsibility to carry out the vegetation management. We trained people and reinforced the technical staff with skills in forest area. Three work groups were created in this new department: monitoring and development, forest planning, and execution management. In the first, with focus on providing tools to control the progress of physical and the financial execution and plan the inspections and regulation of the proximity of vegetation to the power grid. The second, with the focus on dialogue with commissions for the integrated management of rural fires, and the planning intervention in secondary network of fuel management plants. And in the third, with focus on interlocution with the external service providers, planning and monitoring the execution on protection areas and in the secondary network of fuel management plants. As referred in the previous slides, there are two major areas of intervention in our department: protection areas and secondary network of fuel management plants. In protection areas, it is necessary to comply with the electrical line safety regulations. R&D monitors the technical condition of the aerial network by conducting visual, thermographic, and laser measurements of drivers' distances to obstacles, especially by air with helicopter and drones. Depending the results obtained, redes prioritizes and establishes maintenance plans for each electric line to ensure the proper operation of the electrical network, namely by ensuring the regulatory distances from trees to the conductors. Annually, on average, redes performs these inspections in 15,000 kilometers of high and medium voltage of aerial networks. redes is also responsible for fuel management in a lane with 15 or 25 meters wide from the network sections that make up the secondary network of fuel management lanes as defined in the municipal plans. In these graphs, we present the result of redes performance in vegetation management in recent years, in euros and in kilometers. It is possible to observe an increase in intervention in the protection area and also in secondary network. Analyzing these graphs, it's possible to observe that in last year, our investment was higher than 18 million euros, which corresponds more than 60,000 kilometers of interventions. It is possible to say that in 2022 we will maintain the increase in physical interventions in these two areas of work. The development of innovative solutions has been one of the priorities for redes. About the inspection methods, we highlight that aerial inspection currently offers 4 types of information with single flight, being redes one of the first to adopt. Visual and IR since 1994, LIDAR since 2006, and UV since 2012. Our expectations are high, and we intend to optimize the aerial inspections to obtain more and faster information. For example, the information of species and biomass estimation to improve our predictive intervention algorithm. The Replent project could bring us new tools to improve our practice and find the best results in specific areas, from fire risk index calculations, satellite imagery analysis to support forest planning with species identification and execution management with verification work, for example, best practice in vegetation management, analysis of compatibility forest species, improvement of the predictive intervention algorithm, and LIDAR technology optimization for biomass estimation. To conclude, redes intends to promote the best solutions and practices, and Replent is part of this strategy. I think that is all. Thank you for your attention.
Thank you, Fatima. Now we go to the last presentation. It will be presented by André Coelho, André is currently working as Head of Asset Inspection at EDP Labelec. With experience on electric grid access and energy production systems, his fields of expertise includes LiDAR and infrared data collection, both on helicopter and UAV, and specialized data analysis. André holds a master's degree in electrical engineering from the Lisbon Technical University, Portugal, and is postgraduated in the enterprise data science and analytics from Nova Information Management School. Before working on a asset inspection area, André worked in modeling and numerical software simulations of electrical power systems in high voltage testing. André?
Okay, thank you very much. I believe my screen is being shared. Is that okay? Good afternoon, and I will try to structure this presentation in two different parts. The first part, in the first part, I will try to present the asset inspection department of Labelec and the work that we perform, especially regarding the power line inspection. In the second part, I will try to address the rePLANT project and explain how it is related with our activity, and also I will talk to the scope of our participation in the project. Okay, so starting by giving some context on our activity. As most of you may know, we develop our activity in EDP Labelec, which is a company from the EDP group, and we are organized in a set of laboratories and areas to answer specific challenges. This kind of organization allows us to have a large scope of activity and still remaining specialized. In one of those areas called tests and trials, we have a department to dedicate to the power to the asset inspection. And what kind of activity do we perform in this asset inspection department? Basically, what we do is to collect data, we analyze that data, and we create what we call or what we believe that are value-added outputs. And we do that in three types of assets: the overhead power lines, which is our main focus, but also on power plants, substations, and other industrial installations. Looking with some more detail in our historic perspective, in particular for the power line inspection. Well, we started by 1980 with foot inspections, and then in 1994 we introduced the helicopter as a way to improve our operation, and it was a success. So in 1996 we started to use dedicated equipment for that inspection, in that case the use of gimbals, and then, like Fatima said, in 2006 we introduced the LiDAR, and we introduced the LiDAR as a way to verify corridor clearance regarding vegetation. Back in 2014, as drones start to appear, we develop our own drone as a way to answer specific details for power line inspection. Because back in that time, we felt there was no drones developed specific for this kind of inspections. Then in 2018, we changed a little bit our strategy, and we started to use industrial drones because the market started to offer a very good solution for power line inspections. So that's how we reached 2021, and 2021 was a very good year for us regarding our activity. During 2021, we had a team of 14 people working in our area. We used 2 helicopters, and we flew about 1,100 hours of flight. We operated 3 types of rotary wing drones, and we also explored 3 LiDAR systems, both for helicopter and drone. And with these resources, we were able to inspect about 24,000 kilometers of power line. We covered about 96,000 hectares, and we identify about 3,000 points of interest, or 3,000 defects. Looking into more detail at the inspection that we perform on overhead power lines, well, as I said, we start by collecting data, and we do that basically using both helicopters and drones. And what kind of data we collect? First, we collect RGB data, normal picture, we can call it that way, and we use that inspection basically to identify structural defects on the power line and on the power line equipments, like for instance corrosion, broken insulators, and things like that. We also perform infrared inspection. In this case, we are concerned about identifying overheatings in these equipments, and we also collect LiDAR. And like I said, LiDAR gives us the opportunity to detect places where vegetation is close to the power line. Just to give some context, LiDAR is a tool. Sometimes we call it a laser, and this laser can build a very accurate point cloud. And a point cloud, we can think about a point cloud like being a 3D scanner. And this point cloud can be used for several uses. For instance, for autonomous driving, but in our case, we use it for vegetation proximity. And from that output that we deliver to mainly to our internal client RH, it is possible to identify critical situations and prioritize maintenance actions. Okay. Well, taking into account first our experience in power line inspection and of course the introduction of the use of drones, we try to understand why is it good to use drones for power line inspection. And one of the main advantages of the use of drones is, of course, safety, because any incident with drones is have less serious consequences than an accident with another mean. Regarding our operation speed, helicopter presents a big advantage because it can cover much more coverage with the same people and within the same period of time. But on the other hand, drones present bigger flexibility because we can move the operation in a more easily way. Normally, drones, and in particular the ones that we use that are the rotary wing drones, are more adequate for detail inspection, and they are more adequate because we can perform longer flights, longer stationary flights. Regarding costs, it's not so obvious. It depends on several topics, in particular the way that we perform the efficiency of the operation. Nevertheless, drones are paving the way for a potential cost reduction in this kind of activities. And drones are also a very good option to explore new use cases and services beyond power line inspection, and that's one of the reasons that we are also participating in the Replent project. So regarding a drone activity, Labelec is developing our drone activity based on 3 different axes. One is regarding the increase of our capacity and flexibility. We are also using drones for detail inspection, and we are using drones for other use cases where we want to have a better understanding of the feasibility of the inspection. And in this context that we fit the Replent project and our participation in the Replent project. So, talking a little bit about the replants. As it was presented before, the Replent has a wide scope and regarding forest and vegetation managing, and we are helping this project taking part of an activity 1.3, and with particular focus on one specific task, that is the 1.3.1. And basically, what we are trying to evaluate is first the use of drones, and second the use of the LiDAR technology to do biomass quantification. And the objective is to compare this methodology with a conventional way to perform this task. Okay, looking at this fluxogram, so the activity that we are performing can be divided into 5 different steps. First, there is a need for the selecting the area where we perform this task, and it is important that this area have several different vegetation contexts, but is also important to be suitable for drone flights, especially regarding the legal framework of these kind of operations. Then we have the LiDAR acquisition, and by LiDAR acquisition, I mean the flights using drones and the way that we define the best strategy for optimizing this data collection. And then based on the data that is collected with these flights, we need to have the pre-processing. And this pre-processing is basically the point cloud creation, that's where we create the point cloud, where we integrate ground station data to increase the accuracy, and that's the step where we also do the classification, the pre-classification. And by classification, what we mean is that it's where we identify in this point cloud what specific points are ground, what specific points are vegetation, and what kind of vegetation. In this project, we are pre-processing in low vegetation, medium vegetation, and high vegetation. Then other partners of the project can use that output to make the biomass quantification using LiDAR, and also to validate the results on the field using traditional measurements. And this process will allow us to confirm if drones and LiDAR and also the data analysis methodology are a good solution for forestry planning and management. Looking at some pictures of some examples, well, the area selection, also a picture of the LiDAR acquisition, and in the picture of the right, it's possible to see the type of information that we can collect with the LiDAR, and in particular with this project. So to sum up, taking part in this project, we are trying to explore an extra potential of this kind of LiDAR data. Second, we are trying to understand if drones can collect data in this context in an efficient way. And of course, we are trying to give a contribution for forest and vegetation management. Thank you very much.
Okay, thank you, André. Okay, we conclude the presentations. We reserve a period for some questions. Okay, any question, feel free to put by the chat or by the micro.
We already have one question in the chat from Diogo Vieira.
Okay, I think it's for André. Regarding collected LiDAR data, it is used to calculate biomass indicators, is the question.
Okay, I'll try to answer. As far as we believe, yes. What we are trying to provide to our to other partners of this task is a set of LiDAR, of good quality LiDAR, and the idea is to use that LiDAR that is already pre-processed to calculate these biomass indicators, and then to validate this methodology. The idea is to go on the field and to compare the measurements and the results that are obtained based on the LiDAR with the real measurements of the field, and try to evaluate if this methodology is good enough to be used on a rollout situation. I don't know if it is a good answer, but it's my best.
Okay.
I can also say something. Yeah, in fact, other partners that are with the data that are going to be collected through the work of Labelec, they are trying, in fact, to train some algorithms to be possible to not only to quantify the biomass, but also to distinguish between different species. So, and the objective is to have a different kind of map, not only the use map, but also that have this quantifying biomass layer. So I think it's that.
Okay, thank you, Jorge. Okay, the second question. I don't know, Jorge, if you want to.
How are they collected?
Probably is more for Ren. Ren is the partner that is developing this process. in this case, I can say something, not by from our participation in the project, but by the work that we did.
Yeah.
Yes, but go
I
ahead.
can try to answer, well, partly, but then we can, if I think it's Pablo, if he wants, I can then try to get more information. But in fact, that systems are going they are being installed in 3 different areas, one in north and one in center and south of Portugal. They are, well, this is a testing prototype, so, but the idea is to get a commercial version of this kind of systems. They will use the energy from the power lines, I think. So the energy is there, and the communication data is going to be with the network from
GPRS.
Yes, GPRS. So and this is linked to this is a very interesting question, because they are trying to link with the, I don't know if it is the term right, but civil protection system. So they have they can get data that is in real time collected from these systems on the control room, so they can, and they are in connection with them. So they are going to have this kind of information in real time, so they can allocate the teams to the better place. So I think it's that.
Okay, I can. In that case, I was involved in the electrical tests of these cameras. The big question in that case was to decide the best place to install the cameras in the post, in the pole. We are talking about in extremely high voltage lines with high electrical and magnetic fields, and the big question was, where is the best place to install the cameras? The connections is a normal connection, data connection, not so important, but the position of the cameras are really very important, and we test them in our high voltage laboratory in some points of the pole. After doing a simulation of that situation, and I think it's optimized all the process to guarantee that the work of the camera is the one that we want. Okay, Manuel.
There are some tests performing now, because testing these kind of solutions, because in the power lines there are a lot of conditions that are not well controlled, like electromagnetic fields and so on. So this needed to be tested in that kind of conditions. So, but is going on this kind of work.
Okay, the question from an LP is for you, Josh, probably. The question is
how rePLANT applications. No, I have already.
Okay.
But well, we have. It depends what kind of task we are talking about. But in fact, we have REN with these systems are connected with the civil authorities. So the communication between them is going on. and they received the information provided from these systems in the control room. So I just said that. And the other kind of results, of course, we are doing well. We don't have enough results yet. I was, for example, the best species, the pine species from some that we are studying, but then we plan that we are going to involve, of course, all the stakeholders that can be interested by to use this kind of new species and so on. So yeah.
One question for André. When we can test the LiDAR technology in distribution lines in Brazil. So we have in EDP we have a project that it was called the drones project in EDP with EDP Spain, EDP Portugal, and EDP Brazil. One of the decisions it was that we have to share our knowledge in LiDAR inspection with Brazil, and in other way Brazil has a mission to present that knowledge in the fixed winds drone waves. So it's not decided the data, but is one thing that we have in our agendas. So probably in the next future, very close, we will have a correct answer. But André, if you want to say more something.
No, I completely agree with Rui. It's not a technical question. It's just a question of aligning some other aspects. But the way that we perform LiDAR is not dependent on the location that we do that. So I believe Rui is also replied.
André, one question from Paul Souza. What is the future of inspections? Drones, helicopter?
This is a very difficult question, because it will, no matter what is the answer, it will be correct, because well, but to be honest, I believe the future of the inspections will be a mix of several types of tools. I believe the helicopter will continue to have space for performing inspections. Drones, of course, are now and trying to pave the way for a potential cost reduction. So we must consider drones also as part of the future. Not only rotary wing drones, but eventually the fixed wing drones, because they will allow us to extend our scope they will try to, or with fixed wing drones we will be able to cover much more coverage with a single flight. But there is also other technologies like the satellite imagery that are starting to appear, and they will also play an important role in the future of the inspections, of the power line inspections.
Okay, another questions about the cameras. Do you get a 306 degrees view for the cameras? I think the question is but George, do you?
Yeah, I can try to give you an answer. Yes, in fact, one of the parameters that are take into account is the best, like we said, the best place to put the camera, the best infrastructure that can simultaneously cover more area and of course he's going to have the 360 view, and another thing, yeah, and there is going to be some cameras across the area that we want to cover, and another thing is the height of the camera. So the interesting of this system is that it allows to detect a fire in its first moment of when it appears. So the smoke, the columns of the smoke is not a problem, because it detects when the smoke is not very huge, in a very huge dimension. So yeah, I don't know if I.
Okay, thank you, Josh.
And this, yeah, okay, thank you.
Andre, one quality question, which is the relation between the accuracy of the LiDAR and the flight.
Well, regarding the accuracy of the LiDAR, normally it doesn't depend on the velocity of the flight velocity, flight heights, because what we do is we try to build a point cloud with good quality based on that kind of conditions, and it doesn't affect the accuracy of the LiDAR. Regarding the wind speed, the problem of the wind speed, of course, is also related with the flying the drone, but especially regarding the movements of the conductors. It's not a question of less accuracy is of the measurement, but less accuracy because the conductors will be affected by the wind, and as the conductors are affected by the wind, the measurements reflect different scenarios that the stationary scenarios that we normally try to provide. But regarding the accuracy of the LiDAR, it depends mostly on the quality of the equipment itself and the way that it is processed in the back office. Regarding the generation, the 3D mesh or the 3D point cloud being generated in real time is not the best option, because for the good quality of these point cloud, it must be some data from ground stations must be used, and typically this data is only available a few hours after the flight. But we can have some estimation of the point cloud, but it's not the best option.
Okay. Question from an LP about the market for Labelec. If other companies, infrastructure operators like water supply, module operators, gas pipes, if they are a potential client for the LiDAR inspection. Andre,
Nope.
please.
Okay, so as I'm trying to understand, would the other critic buying the LiDAR data? Okay, so for us, we believe that the LiDAR several uses, and the way that we are using, or the uses that we apply LiDAR nowadays are not. They can be extended. That's why we are using drones for this kind of other use cases. So of course we would be interested to analyze other opportunities to provide other analysis on this kind of technology.
Okay, and the last question, we are of the time. Is about the fixed wings drones and the constant landing and lift off. In this case, Andrea, I would like to ask and you to share something about there are new regulation for the drone operation. Can you share with us some information about this? What?
Yes, recently in 2021 there was a major change on the regulatory framework of the drone flights. But regarding the question of Carlos, it's not just a question of the limitation that we face nowadays. They are not completely related with the places for landing and for taking off. They are more related with being able to have good equipment, able to provide a payload with capacity for a lidar, and also the legal framework that is presenting some constraints nowadays regarding the use of this kind of drones. But in the future, of course, this kind of problems will be will not be a problem, because we and also other players are trying to overcome these kind of situations.
Okay, I think we finish the hour that we have for this session. I would like to thank to Jorge, Fatima, and Andre for their presentations and the answer for the questions. Thanks to the audience. I think we were 153 was the maximum. So thank you for everybody.